Okay, so we're going to talk about the matching algorithms used on the D1 exam. And first of all, we're going to talk about bipartite graphs, which are the graphs we use to do the matchings. And then we're going to talk about how to improve a matching that we're already given to make it maximal or complete. Okay, so first of all, let's talk about bipartite graphs. Okay, a bipartite graph looks something like this. And you'll see that on the left-hand side, I've got some nodes, and on the right-hand side, I've got some nodes. And the edges link the things on the left-hand side to the nodes on the right-hand side, and they show the possible ways that nodes on the left can be connected to nodes on the right. Okay, so you can see that A can be connected to 1 or 2, and B can be connected to 1, 2, or 3. C can only be connected to 2, and D can only be connected to 1, 3, or 4. So the information in that graph is how can things on the left be connected to things on the right. Okay. Now we can represent the same information in something called an adjacency matrix. So I'm going to draw out an adjacency matrix now and show you how the information in the adjacency matrix gives us the same information that's in this bipartite graph here. And the way we do it is we just put A, B, C, and D down the side. And then across the top, I'm going to put the nodes on the right-hand side, 1, 2, 3, and 4. And if there is a connection between the node on the left with the node on the right, then I'm going to put a 1 in the matrix. And if there isn't a connection, I'm going to put a 0. So A is connected to 1, so I'll put a 1. A is connected to 2, so I'll put a 1. And it's not connected to 3 or 4, so those are going to be zeros. B is connected to 1, 2, and 3. So 1, 1, and 0. C is connected to just 2, so that's 0, 1, 0, 0. And D is connected to 1, 3, and 4, so that's 1, 0, 1, 1. So the same information on the graph is represented in this adjacency matrix here. And you might be asked, given a graph, to draw out an adjacency matrix, or you might be given an adjacency matrix and asked to do the graph. The other thing that a question might give you is an initial matching. So it might say, here's how things on the left can be connected to the right, but initially A is connected to 1. So it's actually, has been picked a connection. A could be connected to 1 or 2, but initially it's connected to 1. A can't be connected to more than one thing. In fact, each node on the left can only be connected to one node on the right, but this just represents the possible connections that there are. So initially A is connected to 1, and on the adjacency matrix that would be represented by a bold 1. Okay, so the adjacency matrix will tell you how the connections are possible, but if there is an initial connection, it will be a bold 1 rather than just a standard 1. And let's say that B is initially connected to 3. So on the matrix over here, that would be a bold 1 on there. And let's say C is initially connected to 2. So again, that would be a bold 1 over here. And let's say D is initially connected to 4. And again, that would be a bold 1 over here. Now, the way the things on the left have been matched to things on the right, in this case, is called a complete matching, because we've managed to connect everything on the left with everything on the right. Okay? Everything on the left is connected to something on the right, and that's a complete matching. So I'm going to put that down as a definition. A complete matching is a matching which has the same number of edges. In this case, there's 4 edges in the matching, so it has the same number of edges as nodes down one side. So in this case, there was 4 nodes down the left-hand side, And we managed to get 4 edges, so everything on the left-hand side is connected. Now, this might not always be possible. For example, let me draw another bipartite graph, and we'll just have 1, 2, and 3. And over on this side, we'll have A, B, and C. And I'm going to connect it up like this. 1 can be connected to A and C, 2 can be connected to B, and 3 can be connected to B like that. And in this case, I can connect A and 1 together, and I can connect 2 and B together, but that means I can't connect 3 up now. It's impossible to connect 3 up because B is already connected to 2. Okay, and I can't connect 3 to C because there's not a possible connection. So in this case, what I've got there, 1 and A and B and 2, is not a complete matching because I've only got 2 edges and there's 3 nodes. It's a maximal matching. So a maximal matching is a matching with the maximum number of edges. Okay, so now we're going to talk about how to improve on an initial matching. In this case up here, we're given the initial matching and it's a complete matching, so it can't be improved upon. I can't get any more edges in because everything is connected. But let's suppose I'm given an initial matching and there's some nodes that aren't connected, and I think I can maybe do a better job. So the algorithm we're going to look at is how to improve that initial matching. Okay, so improving matching. Here I've got some boys on the left and some girls on the right, and it shows how they could be connected if they wanted to play like a mixed tennis game or something like that. So Alex will join up with Ellie, Faye or Georgia, and Brad will join up with just Faye, Charlie, Georgia or Hannah, and Dan will connect with Faye, Georgia or Hannah. Okay, so that shows the possible matchings that we could have. But we're going to be given an initial matching. And the initial matching is going to be Alex connected to Ellie. So they've been paired. So we've got Dan connected with Faye. And we've got Charlie and Hannah. So my initial matching is going to be A and E. I'll make a note of this like this: A with E, C with H, and D with F. So that's my initial matching there. But there's a problem, and the problem is Brad hasn't got anyone to play with, and Georgia hasn't got anyone. So we want to see if we can do a better job. And the way we do that is we're going to look for an alternating path. And that's a path that starts at a node on the left-hand side, which is unconnected, and moves to the right-hand side and back through the network, back and forth, left to right and right to left, until it finishes on the right-hand side at another node that isn't connected. So in this case, I'm going to start at B, at Brad, and I'm going to move to the right, back to the left and back to the right, and keep going until I finish at Georgia. I'm going to look for that path. Okay, so we're going to start at B, which is unconnected on the left-hand side, and look for G. Now there's a rule to how you move through this path, and that is you start at an unconnected node on the left-hand side and you move to the right on an unconnected edge. But when you move from right to left, you have to move on a connected edge. So I'm going to go B to F, And then from F, I have to go to D. I have to go along this connected edge. I can't go along F to A. So it's going to be B to F and then F to D. And I'm going to write this down. F is connected to D, so I'm going to leave it like that. And D isn't connected to G. And so I'm going to put a line through that connection to show these connections are not there, and this is connected. So this isn't connected, this is, this isn't. Okay, so it's alternating. And this is my alternating path. Let me write that here as well. So if it asks you for the alternating path, that's what you write down. And then what we're going to do to find a better matching is, we're going to write out this path again. And all I'm going to do is swap the connections around. So where B wasn't connected to F, I'm going to now connect it. I'm going to disconnect it from D. So F was connected to D, and now I'm going to disconnect it. D wasn't connected to G, and now I'm going to connect it. So I've switched all of the connections around. Okay, so now B is connected to F, D is connected to G. Now if I go back to my initial matching, A was connected to E. By doing this and switching the connections, A is still connected to E. I haven't talked about an A or an E in this. So now, A is still connected to E. B is connected to F. C, I haven't mentioned. So let's go and have a look what it was connected to at the start, because I haven't changed it. C was connected to H. And D is now connected to G. And everything on the left is now connected to everything on the right. So I've got a complete matching now. I've improved the matching, so it's improved, and now it's complete. And that's how you improve a matching from an initial matching. Now it might be that two things on the left are not connected, and two things on the right are not connected. So you will do the algorithm once, and then you might have to do the algorithm again. Okay. This one was quite short as well. I only had to go from B to F to D to G. It might be that you have to go back and forth a few times, but as long as you go to the left on an unconnected one and go to the right on a connected one, eventually you'll get to the node you need to be at, and then just switch all the connections around. So now we're going to do an exam question to see if we can do all the things we've learned. Okay, so we're going to do this question from May 2012. Is that that's the paper, isn't it? So question 1 is, represent the information on this bipartite graph on an adjacency matrix. Did you manage to do that after a while? Yeah. So all I do for an adjacency matrix is A, B, C, D, E, F down the side. Okay. And this is just a different way of representing the same data. So I've got 1, 2, 3, 4, 5, and 6 across the top. Right, A is connected to just 3 and not anything else. B is connected to 1 and 4 and nothing else. C is connected to 3 and 6 and nothing else. D is connected to 1 and 2. E is connected to 4 and 5. Always do that. 4 and 5, like that. And then F is connected to 5 and 6. Did everyone manage to do that? Yeah. 2 marks. Okay. Right, and then it says, this is usually how these questions work. You're given the matching, and then it will give you an initial matching. It will say they've already tried to match something up. So your initial matching, it says there's an initial matching, and B is assigned to task 4, so B goes to 4. C goes to 3. C is assigned to 3. D is assigned to 1, and E to 5, and F to 6. Is that right? Okay. So let me just, I'm going to just draw it on there for the time being, just so you can see what's going on. So let's use that colour. B is assigned to 4, so there. C is assigned to 3. D is assigned to 1. Now you don't have to do this on your paper, just helps you picture it. E is assigned to 5, and then F is assigned to 6. So what's the problem with that initial matching? A isn't joined to anything. So we would say this isn't a complete matching. Do you know what I mean by a complete matching? When I've got the same number of edges highlighted, or the same number of edges connecting as there are nodes down the side. So there's 1, 2, 3, 4, 5, 6 nodes down the side, so I'm looking for 6 edges, and then I'll have a complete matching. Okay? Good. Now it might not be possible to do it. In this case it probably is, but it's not always possible. So if you can't have a complete matching, you can get a maximum matching, which is just as many edges as you can, you see what I mean. Okay, so can anyone remember the method, the algorithm I used to find this, to find a better matching? Yeah, you start on the left-hand side of something that's not matched. So we're going to start at A. Okay, so I'll put that here. Start at A. Yeah, and we're going to look for something on the right-hand side that isn't matched. So what am I looking for? Look for 2, yeah? Do you understand what I'm saying? So I'm going to start at A, and I'm going to try and find a path through the network that goes from left to right and back and forth like this, and finishes at 2. Okay? And that there is going to be called an alternating path. And the weird thing with this question is you have to write all these things down. So I would always write on the exam paper, start at A, look for 2. Okay? And we're going to find a path. What is it about the way I move through the network from left to right and then right to left? Yeah, so when I go from A to the right, so it will be A to 3, I always move from left to right on an edge that isn't connected. And when I move right to left, I move on an edge that is connected. Does that make sense? Shall I say that again? I start on the left on the node that isn't connected. That's why I'm starting at A. So when I move from left to right, I always move from left to right on an edge that isn't connected. Okay? And then I move from right to left on an edge that is connected. And it's got to always be like that. So when I go from right to left, I have to move on one that is connected. It's an alternating path, so that means you move from the left to right, unconnected, right to left, connected. Left to right, unconnected, right to left, connected. Alternating. That's what it's called, an alternating path. Okay? Right, so let's see if we can find a route through. We're going to go, start at A. From A, I'm going to go to 3. And I'm going to use this notation. I went from A to 3, and they weren't connected, so I'll put a line through it like that. Okay? From 3, where do I go? I can only go to C. 3 to C. That was connected. From C to 6, is it? That's not connected. From 6, F. This isn't very good, is it? It's going to be a long one. And from F to 5, yeah? Okay, and from 5 to E. Okay, let me come down a little bit. And from E, I'm going to go to 4, and that's not connected. And from 4 to B, is it? Let me just move it up a bit. 4 to B. Jeez. 4 to B, and then from B to 1. Yeah. From 1 to D, and then D to 2. Okay, so it's quite a long, I think we've visited every single node on the way through there. Notice we go A to 3 is unconnected, 3 to C is connected, and so on like that, and it's got to be alternating. Okay? Can anyone remember what I'd write down now and found this path? I usually write down breakthrough. Yeah, so I found a breakthrough. Yeah, you see it on the mark schemes, it's a bit weird. So breakthrough, I found it. Okay. And I'm just going to make notes. I'm going to write this out again. The path, the alternating path, sometimes it asks you for the alternating path. I'm just going to write this out again, all in one long line. So it was A to 3 to C to 6 to F to S. Is it? It's my handwriting. That's 5. E, 4, B, 1, D. Okay, and there. So there's my alternating path. And what do I do now? Yeah, I swap the connections around. So I'm going to write this out again, and I'm going to connect A with 3 and disconnect it from C, and connect C with 6, disconnect it from F, connect F to, that was a 5, wasn't it? Disconnect it from E, connect it to 4, disconnect it from B, connect that to 1, disconnect it from D, and connect D to 2. Okay? So now, I'm going to write down, it says, by using an algorithm to find this initial matching, find a complete matching. Okay? So now, I've got that A is connected to 3, I've got the B is connected to 1, C is connected to 6, D is connected to 2, E is connected to 4, and F is connected to 5, and everything's connected. So this is the complete matching, because it's complete because there's the same number of matchings, 1, 2, 3, 4, 5, 6, as there are nodes. Okay, any questions? That's pretty much it. There's only two things. The only two things I can really ask you is they might give you the matrix first, then ask you to draw the network, the other way around. So they might give you this thing on the right and get you to draw that, but that's okay. And usually they just give you an initial matching and you have to improve it. Now this question is nasty in one way because the route you had to take was very long, but it's not really, it doesn't really make it any harder. If you just keep going through the route, you'll eventually get to the one you're trying to get to. The only thing that could make it harder is if two things on the left weren't connected, you might have to do one path, and then you might have to draw the connections out again, and then do it again, do the algorithm again to connect the other node up. That would be the only thing, but it's the same skill. Okay? Any other questions?
What were the method marks being for?
The method marks, would you like to see the, should we look at the mark scheme? Okay. Okay, so the marks. You've got one mark for just doing a 6x6 matrix, and it doesn't really say where the zeros and ones are, just for doing a 6x6 matrix, that's a mark. Looks like it, yeah, and then a mark for them being in the right place. This part B is saying start from A or start from 2 and work the other way through, okay? So here's the route that we had, and it's that long thing, so you get a mark for that. You get a mark for starting from A, and then basically the third mark is for getting the match.